All right, so if you look under the number 13 question, there's a chart and it has some shapes. And so if we look at that, we see a linear molecule, and for your warm-up today, you drew carbon dioxide. And so if I go back and I draw carbon dioxide again, you have a carbon, and it was double bonded to 2 oxygens, and then the oxygens had each 2 lone pairs. And so if you look here, there's what carbon dioxide really looks like, and then you can see the double bonds. So if I show you this, what's happening here, remember these double bonds, they only really count as one electron domain, and I'm going to call it like a an area of electron density. It's all the same. So if I spin this carbon dioxide and I let it go, it's always going to rest back at 180 degrees. These 2 electron clouds, these areas of electron density, they're going to try to get as far away from each other as possible. And so in 3-dimensional space, as far away from each other as possible is 180 degrees. And so this Lewis structure really does look a lot like the actual molecule. And that's not always the case, but it is the case on this one. If I go over now and we actually build this, I'm going to leave the Lewis structure right there for you. We're going to take, and I'm just going to come around to each table and steal some candy. One at a time, so I'm not going to steal anybody's candy altogether. But if you take 2 toothpicks, and we'll do red for carbon here. Red's typically oxygen, but that's okay. And so we're going to have this central atom. That's my carbon. And here's my 2 oxygens. Yeah, oxygen's red, carbon's black. Doesn't matter. Those kinds of candies are gross. So, and, you know, this is really a single bond here in this picture, but it would still be linear if it was somehow able to do a single bond. So that's the VSEPR shape for carbon dioxide, and this is linear. So build that, and we'll come back together. So you have a lot of candy and a lot of marshmallows and stuff. You may not have enough for everybody to build every single one. Maybe take turns, something like that. That'd be fine. All right, and so the bond angle on that one is pretty straightforward. It's 180 degrees. What I have now, if you look on your POGL, the next shape is trigonal planar. In math class, the word planar means something. I'm going to pick somebody. So think about the word plane in math, not in the sky. Brendan, what is a plane in math class? Can you give me like an idea? It's an area, and it's, what shape is it? It's flat and extends in all directions, and it's flat. Is that like ringing a bell? All right, so trigonal, sounds like really intimidating. The shape of this molecule is trigonal planar. Ooh. Well, okay, that's really not that scary because it's a triangle and it's flat. Let me show you how it's flat. See? It's flat in a plane and it's a triangle. Trigonal means it has 3 angles, 1, 2, 3. And if you have 3 electron clouds or areas of electron density, 1, 2, 3, the farthest you could get away from each other would be 120 degrees. And so this right here is going to be my boron trifluoride. And boron is an exception to the octet rule. And I could draw the lone pairs on the, that's a really awful triangle. I could draw the lone pairs on the boron if I, not boron, on the fluorine if I wanted to. I'm not going to, but you know, that makes you feel better. There. Okay, I did it. And so that's my Lewis structure, and then that here, this is my VSEPR shape, and so the name of this VSEPR shape is trigonal planar. And so when we go to draw this, let me show you how I can rotate this. And they're always going to establish this 120-degree angle. When we go to make this molecule, we're going to get one atom. The central atom is going to be one color, and then use a different atom, a different candy color for your terminal atoms. So if I go back, I'm going to borrow these guys' candy this time. Y'all have a lot of red, it seems like. So let's get 3 reds for our fluorines, and let's just do maybe yellow, more than that. And we're just going to get a central atom. So here is my boron, and just make a triangle about 120 degrees from each one, kind of like a Mercedes-Benz sign, if you want to think about it like that. Yay! And we're just going to connect it, and there you go. This is trigonal planar. It makes 3 angles. That's where the trigonal is coming from, and it's flat. So when I look at it, it's flat, and that's trigonal planar. So there you go. I'll give you a chance to build those with your candies. Looks good. I see some look more like a T. T-shape is actually a more advanced VSEPR shape that you don't know about and that we're not going to talk about today. So do make this look like a triangle.
Is that part of the flow?
Yeah. I'll show it to you in a minute if you're very curious. So get your trigonal planar down, and next on your POGL, looks like we're going to tetrahedral. So see some people still building. I'll give you a second. If you all build all these, you're going to run out of stuff. So just, you know, like I said, maybe half of you build one and then the other half take turns. Hello. All right, so the next VSEPR shape on your paper is tetrahedral. And so when I go in here, the most common tetrahedral shape is methane, and methane is CH4. And so when I'm looking at this one, I'm going to situate it like this. That's the easiest way to look at it. This is really the first one that looks a lot different than the there we go, than the Lewis structure. So let me draw the Lewis structure for methane. And so when I do that, I have a carbon as my central atom, and then you just had those 4, so this is CH4, methane, okay? That looks a lot different than that, and this is the first one. And so when we look at the bond angle in a tetrahedral molecule, I have 109.5 degrees. And so if you think about 3-dimensional space, and you're thinking, okay, well, 360 degrees divided by 4, that doesn't give you 109, but you have to think about it, you have this sphere to work with, right? And so the farthest you can get away from each other in 3-dimensional space is a little bit greater than you would be able to do on a flat piece of paper. And so it's 109.5 degrees. So anyway, let's go ahead and build this one. The name of this is tetrahedral. And so if you could think about it, see if I can kind of draw this in. I don't know if I can. I'll try my best. Y'all know I'm so good at drawing, right? Mm-hmm. Yeah. It's like, ha 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 ha. Miss Freeman is so funny. You could actually think about drawing in like, I'm trying to pick pink. You could draw in like a pink pyramid shape here. Like that's one of the faces. And then there would be another triangular face to this shape right here. And then there would be one on the back and one on the bottom. And that's where that tetra means 4 is coming from. So there would be like another plane on the back side and then on the bottom. And that's where this name is coming from. But let me erase that. This one's harder to do. So let me help you do this. Let me get my shapes from this group. I'm going. Okay, so here we go. I have a central atom. And this, if you'll take and kind of watch me, oops, let me switch my screen over. If you'll kind of watch me before you do this one, I think you'll get a little bit, you'll have a little bit of an easier time, to be honest. So, I go here, my central atom, kind of leave it to the side. What you're doing, have you ever taken and like made a tripod for a camera? Mm-hmm. Basically, you're making a tripod. And so, my central atom, I'm sitting to the side. I'm not messing with it yet. I'm going to go ahead and build the legs to my tripod. So if I take a dot and I insert this at about that angle and sit that to the side, I'm going to do that on all three of these bottom ones. So there. Just kind of go with me, just watch, and then you can do it yourself. Kind of at this angle. And then I'm going to insert those into the bottom of my central atom. And think about it, like I said, like a camera tripod. And it should, from the top, it should make a triangle, something like that. And then you can insert the top one. And so, should be like, that's actually not too bad, should be something like this, where it's a triangle from the top, and then you have one sticking out. So, you got a camera tripod, and there's your camera. But, you know, there's my 4 hydrogens, 1, 2, 3, 4, and there's my carbon. So, see how that one goes. It's a little bit more difficult. Okay, so this is a tetrahedral shape. And the bond angle, again, is 109.5 degrees. So you already have one. Let me borrow this one. I'll do it there for everybody. Thanks. So try to build this one. And if you do it exactly right, you know, you should be able to spin it any direction and it should be the same. That isn't typically how it works out, but that's an ideal world. Yeah, they kind of, they give in and give way. Sure. There you go. So that's tetrahedral. Everybody get a chance to build that? That will, if it was your turn. All right, so moving on. The next one on your POGL is pyramidal. And pyramidal is very similar to tetrahedral, and I'm going to get into why it's called something else. So this is my ammonia here. And so if I go ahead and draw the Lewis structure for ammonia, I have my nitrogen, and we did this on the warm-up. So my nitrogen's here, and then you had hydrogen, 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 and you had a lone pair. Now, watch this. As I rotate this molecule, it looks very similar to the methane that I had a second ago. But as I rotate this, you see the top of this tripod is no longer an atom. That's actually those 2 dots. That's my lone pair, and I can actually make the lone pair go away. Without the lone pair, if I was in Egypt, what would the shape be? Yeah, and so here's the trick, okay? This is kind of previewing a little bit more advanced chemistry, but you make the shape according to all the electrical domains, but you name it without the lone pair. So I'm going to call this a pyramid, even though it's got this lone pair, because what's going to be the marshmallow, which is your lone pair, that doesn't go into the name. So without the lone pair, it's a pyramid, and so it's called pyramidal. And it's actually trigonal pyramidal because the bottom is a triangle. Very complicated stuff, right? I mean, it kind of is, but it's not that bad. If you kind of break it down, get some candy, it makes it go down a little smoother. So let me build this one for you, kind of show you what's going on. So this one, the lone pairs actually take up a lot more space. I should have mentioned that. The lone pairs, look at how much space they take up. It's quite a bit for 2 electrons. And the way I think about it is, if you're looking at this, if you think about a dog in your yard, and this is electrons that are bonded to this hydrogen and carbon, hydrogen and nitrogen. If you had a dog in your yard and it was tied on like a dog run, it would be stuck between these 2 areas. These lone pairs, they're not tied up. They're running around in the yard, so they take up quite a bit of room. See? And so that's just the way I like to explain that. Does that kind of make sense? Yay! All right, so let's build this. You need a marshmallow. You need 3 terminal atoms of one color, and you need a central atom of a different color. So you're gonna build a tripod just like you did last time. The bond angle is a little bit different. I'll show you that in a second. So get your tripod going, just like last time. Oops. So make your little tripod, and then your long pair. I'm gonna stick the what is this called? The toothpick all the way through it. I'm over here telling you like the names of this crazy stuff. I'm like, what's this stick called? So this is really cute, I think. Look at that. Ballin'. Okay. That's very pretty. So this is trigonal pyramidal. So there's the triangle. Woo! I'm having a little bit too much fun. Okay, who's this one? So let's just like the last one, except it has a marshmallow on the top. Okay, now. Alright, just for instructional purposes, not trying to call anybody out. Do you see how these are really pushed down? Are these bottom ones as far away from each other as they could be? No, so that's the issue. Everybody's trying to get away from the other electron clouds because they're all negatively charged and repelling one another. So that's a little better. Okay, those are free zones. That's just for instructional purposes. Isn't this fun? Yay! Okay, I do want to kind of touch base on something real quick before we move on. Look at the bond angle here on these bottom atoms. It's around 107.8 degrees. It is 107.8 degrees. The other one, do you remember tetrahedral was 109.5? This lone pair takes up more room than that atom that would normally be in tetrahedral. So it pushes this base further down, and so you do get a smaller angle on this one. That's just kind of fun facts. The last one you have is bent, and so here's our friend water. And so if I go and draw, I'm going to draw the Lewis structure for water. I'm going to draw it the way that you guys did for your warm-up, and then I'm going to draw it the right way, and then I'm going to show you the shape. So anyway, if you were drawing your water, which like we did on the way in the door, well, that's the right way. It's hard for me to draw it the wrong way because I know the right way. But a lot of you guys have this, and that's okay. And you were like, doo-doo-doo, doo-doo-doo. Okay, fine. When you're drawing the Lewis structure for water, you really want to draw it more like this. But that's not the same as this. And so let me kind of show you what's going on here. That oxygen has 2 lone pairs, and so those are taking up quite a bit of room. Woo! So there's my 2 lone pairs. I think it's upside down for my picture. I'll make it better. It's kind of hard to do. There. So there's my 2 lone pairs, like these 2 lone pairs. Now notice these hydrogens, they're in a different plane. They're going straight back. Okay, so let me wiggle it around so you can see what I'm saying. There you go. So they're kind of perpendicular to each other. Yes. Oh, you did the things. All right. Well, if you look at this, now think with me, this really looks a lot like a tetrahedron, but because it has 2 lone pairs instead of no lone pairs, or 1 lone pair with a trigonal pyramidal, you get an even smaller angle. Now I'm at 104.5 instead of 107.9 or 109.5. Don't worry so much with the numbers. That'll be extra credit. Don't freak out. So anyway, let's go ahead and build this. Please watch me because I am getting paid right now, and I'm trying to help you. So let me give me some marshmallows. So you want 2 marshmallows if you have 2 long pairs. And then I need 2 Alright, so what we're doing now, the easiest way to build this one is you're going to take and make a little angle, like a Mickey Mouse. Yeah, everybody heard, have I told you that water looks like Mickey Mouse? I'll show you how it looks like Mickey Mouse in a second. There's my oxygen, and here's my hydrogens. It's the Mickey Mouse clubhouse. Come inside, it's fun inside. There. So that's now this is the oxygen, and those are the two hydrogens, which is all well and good, but then the lone pairs, they have to go at another angle. So your lone pairs are actually going to be here and here. So marshmallow fun times. Marshmallow fun times. So if you do it just right, it'll stand up. I'm not saying I did it, but I'm saying that's possible. Just, yeah, like that. But bottom line is the hydrogens in the... Let me just get this on video. Miraculous stuff right here. I'm just going to leave that there. I'm going to go home now. So that's your water. And when you're looking at the actual atoms, they're bent. And so we're not going to call this anything with any kind of pyramid or anything, because these lone pairs, they don't go into the name. So this is just called bent. Another bent molecule will be H2S, but whatever. So there's those. And just for fun, just to make you sad inside, I'm just kidding. But just for fun, I do want to show you that there's a lot more than this. We're not going to do those today, but those were all the ones that you're going to be required to know, for me anyway. But like, this gets really complicated and fun. So you have, there's square pyramidal ones. Isn't that fun? Yeah, and then xenon can bond. We talked about that. And it's called square planar. Look, the atoms are in a plane and they make a square. Very nice, right? So all these really, they look super intimidating and weird. So here's another linear possibility, because the atoms are in a line. Don't worry about all this. I just want to, some of y'all are curious and some of y'all are like, oh, okay, I'm done. My brain's full. This one is octahedral. It would have 8 triangles around it. And I don't think I showed you this one. Here's 2 pyramids. So, yeah, to be continued next year or in college, but there's a lot of these. I don't remember. 1, 2, 3, 4, 5, 9, 10, 11, 12, 13. And I think we're doing 5. There might be more than this. I don't see, there's T-shaped. I don't know if I saw T-shaped and seesaw. Oh, there's seesaw. So, there's and it looks like a, would you like to see a seesaw? It goes like, I can make it work. I'm saying that I can make it work. There it goes, there it goes, there it goes. There's a seesaw. There's a kid, there's a kid. This is the handlebars, and that's what it's sitting on. All right, there. Whee, whee. Yeah?
I feel like they could have came up with a more sophisticated thing.
There's a, did I show you T-shaped? Did that happen? There it is. So there's a T-shape. And you know the thing is, the atoms are shaped like a T. And the lone pairs don't count, right, when you name them. Ta-da! That, Lindsay, you made this a minute ago. Let's be honest with you. You did.
I what?
You made this a minute ago. That was a thing. For the trigonal planar. Some of y'all were getting like really sophisticated. Y'all were making like seesaws and T-shapes. I mean, not on purpose, but when I see them, I'm like, oh, that's this. And so, good job. So that was fun. I enjoyed myself. Moving on now. What I want y'all to do is I want you to finish your POGL, and those pictures on your paper, that's not really the same as having some marshmallows in front of you. That's not the same. So use your models that you just made out of candy to finish your POGL, and it should go real easy now for you. And I'll stop this for the people at home.